So let's go back to the beginning of chapter 3 here, where we introduced yet another instruction, and that instruction is the decrement file register skip 0. So this instruction is widely used to support across all the PIC families of microcontrollers from PIC 12 to PIC 18. Okay, and I suspect it goes beyond that since we're dealing with the realm of assembly language. So in looking at this, if we look at the structure of the syntax here, dec fsz, the file register, comma d decrement the file register, and skip the next instruction if 0. So in this instruction, the file register is decremented, and if its content then reaches 0, so we're counting down till it gets to 0, it skips then to the next instruction. By placing a go to target instruction right below it, then we can create a loop. Okay, and we can see that if we look at let's go forward here. If we look at the way the instruction is laid out, again, we've got a go to. So go to again. So we'll take a look at this and take it apart. We went through the pseudonyms and the code producing the flowcharts. So if you need a review on that, go back to those instructions. Okay, so we've got a sample here of writing a program to do a couple of things. First, we want to write the program to clear the working register, and then we want to add 3 to the working register 10 times and place the result in one of the special file registers of port B. Okay, we're going to use the decrement fsz instruction to perform looping, and the solution will look something like this. So as we go through this line by line, we can see that we've got our count equaling a location, in this case the location 0x25, yet another way to identify values in our programs. It uses location 25 hex then for a counter. So as we go through this, the explanation is that the decrement fsz instruction will decrement the counter, the file register at location 0x25, which has a 10 in it. It becomes then 9. Because it's not 0, it will execute to the go to again. So we've got a couple of statements here that we've named. We've got count and we've got again. So we've given them names for these instructions. So the go to again then goes back to the start of the loop. Next, it decrements. Our counter then becomes 8. And because it's not 0, it executes the go to again. It goes on like that until the counter becomes 0. Upon the counter becoming 0, it skips the go to, which it gets now out of the loop and executes the move WF to port B instruction. Notice that we use decrement fsz count F and not decrement fsz count W, because we want the count value to change with the next iteration. We will never get out of the loop if we were to use the other decrement fz count comma W, because count equal to 9 and the decrement value would be placed in the working register. So you can see everything that goes on here on the top is counting down until we reach 0 each time that it does the test, and it's not 0. It tells it then to go to again, and it repeats until it finally gets down to 0. At which point then it will move the working register value to port B and send the sum to that special function register. Okay, so looking at an example of decrementing our values. Okay, so we've got here again the instructions that we just went through. So take a look at that. Make sure it makes sense to you, that you understand this decrement and the reason why we could not write the count value with the working register, because then it would not get out of the loop. So another looping instruction that we need to take a look at is the B and Z for looping. B and Z instruction in looping: branch if not 0. So B and Z, branch if not 0. Again, it's supported by the PIC-18 family, not for the PIC families 12 through 16. So this was an improvement that was picked up at the PIC-18 level. Okay, it uses the 0 flag in the status register. The branch if not 0, B and Z instruction then is used as follows. So if we look at this simple little instruction set here, we've named the first line back, and which becomes the start of the loop. And then we have body of the loop as it is branching if not 0. Then now we have a decrement F, which is just a decrement of the file register. In this case, Z equal to 1. If Z is equal to 1, if the Z is equal to 1, if the file register then is 0. The next instruction then, branch if not 0, back, gives the instruction to go back to the start and branch to the back unless we have Z equal to 0. So in the last two instructions, the file register is decremented if it's not 0. It branches or jumps back to the target address referred to by the label. Prior to the start of the loop, the file register is loaded with the counter value for the number of repetitions. Notice that the B and Z instruction refers to the Z flag, and we talked a little bit about this in class, where we said we were going to start looking at those flags. So in this case, we're going to look at the Z flag. It refers to the Z flag of the status register affected by the previous instruction, decrement F. Okay, and we'll see an example on this. So in our little program here, we're going to write a program to clear the working register and then add 3 to the working register 10 times. Use the 0 flag and the B and Z to write this code. Okay, so in this example, we are going to use then the location 25H again, 0x25 is used as our counter. The counter is first set to 10, and with each iteration, the decrement instruction decrements the file register and sets the file bits accordingly. If the file register is not 0, it jumps to the target address associated with the label again. And so we can see that again. We've got our counter part and we've got our again label. This looping action continues until the file register count becomes 0. After the file register count becomes 0, Z equal to 0, it falls through the loop and executes the instruction immediately below it. In this case, the move WF to port B. Okay, so where is our move? There it is, the last line in here. Move WF point B sends the sum then to the port B SFR. Okay, notice that the decrement F count F instruction that the file register 25H is used as a register to hold the count as it decrements instead of the working register. If the working register is used as the destination of the decf instruction, then you will end up in an infinite loop because the count remains at its original value of 10. Okay, so branch, if not 0, then becomes our next example for understanding assembly language and how we put it to use using flags and the decrement values. Okay, so again here, if we take a look at this, that same instructions and the explanation for that little program. Okay, so we started to use all of those instructions that we've seen so far from chapter 2 in understanding how to write simple programs, in this case to do a decrement, which might be something that we use as a timer of sorts to capture maybe an event. Okay, so in looking at this then, using the flow chart here, notice that the decrement F count F instruction that the file register 25 is used. So if you follow through on the flow here of the flow chart, you can see the decrementing action and then the tests that go on. You can see our test down here. It keeps looking to see if the counter is 0. If the working register is used as the destination, then the decf instruction, again, as we said before, we would have an infinite loop. The count remains then at its original value. So it would never decrement, and this would not then serve the purpose that we're looking for this little program. So the next thing we're going to look at is something known as a nested loop, or a loop inside a loop, to try to understand how we can create loops that are doing multiple countdowns or functions, one inside of the other.